Next chapter we're going to look at, chapter 11. Chapter 11 really deals with inverses and exponents and a bunch of different things with chapter 11. Looks like we'll probably cover all four sections in chapter 11. So let's go ahead and get going with chapter 11. So today we're going to talk about inverse functions. So we talked about piecewise functions, we talked about composite functions and those types of things in chapter 10. Today we're going to talk about and discuss we're going to talk about inverse functions. So a few different objectives today. We're going to decide whether a function is one-to-one, and if it is, be able to find its inverse. We're going to use what we call the horizontal line test to determine whether something is a function or not. And then we're going to find the equation of the inverse of a function. And we're not going to worry too much about 4 and 5, graphing them or using the graphing calculators today. So first one, we're going to decide whether a function is one-to-one, exactly what one-to-one means. And then if it is, find what we call the inverse. So a one-to-one function. In a one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. So again, in a one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. Okay, so we kind of got this type of situation going on, where if we look at the first one is not one-to-one, because if we look at the x values, which are the domain, these are essentially our x values, these are our y values. Again, this is our x value, that's our y values. If we look at the first one, we say 1 maps to 6, 2 maps to 7, and 3 maps to 7. Because this situation happens right here, because the x value is associated with one y value, that makes it not a one-to-one function. Or if you look at the other one, you'll notice that each of the domains goes to exactly one of the ranges. So that makes that a one-to-one function. Again, it can only go to one thing. It can't go to multiple things when we're talking about something being one-to-one. So then that leads us to a definition of an inverse. The inverse of a one-to-one function, written f-1, that's how we represent an inverse, is the set of all ordered pairs of the form yx, where xy belongs to f. Since the inverse is formed by interchanging the x and y, the domain of the f becomes the range of the inverse, and the range of f becomes the domain of the inverse. So essentially, if we've got a one-to-one function and we want to find its inverse, we just flip the x and the y values. You just switch the x and y values. What was an x becomes a y, and what becomes a y becomes an x. What was the domain becomes the range, and what was the range becomes the domain. So in this case, we want to determine whether the function is one-to-one, and then if it is, find its inverse. Because if it's not one-to-one, you can't find its inverse. So 2 goes to 5, 3 goes to 6, 4 goes to 8, and 8 goes to 7. So if I look at my x values, the x values only go to one y value. The y values aren't repeated. So it's a one-to-one function. Each x value corresponds to only one y value, and every y value corresponds to only one x value. So this function is one-to-one. So you look at it the other way too. 5 and 2, 3 and 6 and 3. It works. So now when we're going to find the inverse of this, since it is a one-to-one function, we want to find the inverse, we're just going to switch the x and the y values. So what was an x becomes a y, and what was a y becomes an x. So our inverse of this is 5, 2, 3, 6, or 6, 3, 8, 4, and 7, 8. And you're done. That's the inverse of it. You just switch your x and y values after you've determined that it is a one-to-one function. Okay? So let's look at another one. 0 to 3, -1 to 2, and 1 to 3. You'll notice that 0 goes to 3 and 1 goes to 3. Right there, it's not a one-to-one function anymore. So since it's not a one-to-one function anymore, we're not even going to worry about finding its inverse. Okay. Next one. It says a Norwegian psychologist has developed a rule for predicting run times based on a time to run 5K. An example of one runner shown here is if he goes 1.5K in 4:22, he goes 3K in 9:18, 5K in 16, and 10K in 33:40. So it's kind of a one-to-one function. We've got different things going on because each x value or distance corresponds to one y value, time. Okay, so we do call this a one-to-one function. If we do the inverse of it, time and distance just switch places. So the time becomes the time and the distance just switch. Okay, so time becomes 4:22. It's just switching the tables. Okay, is all that does. Okay, so that's how we determine if something is a one-to-one function or not when we're looking at kind of those ordered pairs. The next thing we want to talk about is what we call the horizontal line test to determine whether a function is one-to-one or not. So a function is a one-to-one function if every horizontal line intersects the graph at most in one point. Okay, so we got kind of that parabola thing, and we said that that was one-to-one because we said it was a function because we could do the vertical line test. Now this is a horizontal line test, so we have to be able to draw that horizontal line in there as well with no intersections to determine if it is one-to-one. So if we look at these two drawings, in A, we've kind of got that inverted parabola. So if I draw a horizontal, this is horizontal. If I draw a horizontal, I'm going to intersect, and they probably do it. So I'm not going to. But if you notice that that horizontal line intersects that graph in two places, since it intersects that graph in two places, that is not a one-to-one function. Simple and as easy as that. If we look at B, if I draw a horizontal line there, it only hits it in one. Now it has to be all horizontal lines just hit it in one spot, but I think if I continue, we just kind of slid that up and down, it's not going to matter. It's still going to be a one-to-one function. Okay, so that's what we call the horizontal line test. Pretty simple, pretty straightforward. So the next thing we're going to do is we're going to find the equations of the inverse of a function. And this is the last thing we're going to do. And I actually may write even in this part, but we'll see. Okay, so finding an equation in the inverse of y equals f of x. For a one-to-one function, f, defined by the equation y equals f of x, the following equation of the inverse is follows. So this is how we're going to do it. Step 1, we're going to interchange the x and the y. That's step 1. Step 2, we're going to solve for y. And step 3, we're going to replace the y with the inverse sign, and that's the inverse for the sign. Okay, so those are the steps that we're going to use. Okay, so if we look at this, so we've got f of x is equal to negative 3x minus 4. Decide whether the equation is a one-to-one function. If so, find the equation that defines its inverse. Okay, so we're going to assume that it's a one-to-one function in this case. Okay, so the first step that we are going to do is I'm going to rewrite it as y equals 3x minus 4. Okay, so that's really step 1. They said f of x equals y, so that's why we could do that. Their step 1 then said interchange the x and the y value. So what was an x becomes a y, and what was a y becomes an x. So I'm going to rewrite this as x is equal to 3y minus 4. That was kind of their step 2, or step 1. The next step is to solve for y. So we're going to take this equation, x equals 3y minus 4, and we're going to solve it for y. So I'm going to add 4 to both sides because I got to isolate that y. So we've got x plus 4 equals 3y. Now we have to divide by 3. So we get x plus 4 over 3 is equal to y. And then the last step they said was to write it as an inverse. And I'm just going to switch it around here. So f negative 1 of x is going to equal x plus 4 divided by 3. And that is the inverse of f of x is equal to 3x minus 4. And you're done with this one. So we change the f of x, we make that a y. Switch your x and y values, because that's what inverses do. And then you solve for y. And then finish it up by writing the inverse symbol f of negative 1 of x. Okay? So let's see what they do. They graphed it. It's a non-vertical line, so it's 1-to-1. And so that's our first step that we did. They flipped the x and the y values just like we did. They switched it around, which is okay. And that's what we had, and then finished it off by writing the inverse of it. All right, the next one. Okay, so this is cubic. It's going to be 1-to-1. And in your assignment today, yes, they're all going to be, I made sure in your assignment that they were all 1-to-1. I mean, we could graph these on a graphing calculator and do the horizontal line test, or you could go into Desmos and do the horizontal line test if you want to check to see if it really is. But I tried to make every single one 1-to-1. So, okay, so there's first step. So our first step then, we're going to go y is equal to x cubed plus 1. That's step 1. Step 2, we're going to switch our x and the y's. So this is going to be x equals y cubed plus 1. Now we're going to solve for x. Solve for y. So we're going to subtract 1 from both sides. And then we take the cubed root. That's going to equal our y value. And then we change it to a inverse. And that's our inverse of the function x cubed plus 1. Okay. Let's take a look at their explanation. So what we did, that's what we did. They flipped it around. Again, not a big deal. That's what we had for our inverse. So we got the same thing they did. So x minus 3 squared is actually a parabola. If we were going to graph this one, this looks like this. So you got that horizontal line test thing going on. So this is actually a parabola, so it is not a 1-to-1 function. So if it's not a 1-to-1 function, we can't really find its inverse. Okay, I want to do one more of these. I know it says graph, but I want to do one more of these to make sure that we're okay. Whatever. Make sure we're okay. So let's say that we have g of x. It's no different. G of x is equal to the square root of x plus 3. Okay, so if we graphed this, it's 1-to-1. So we're going to change it into y equals the square root of x plus 3. Switch your x and y's. So x equals the square root of y plus 3. Have to get rid of any of the square roots. We're going to square it. So we square both sides. So that gives me x squared is equal to y plus 3. Subtract 3, x squared, x squared minus 3 equals y. So f negative 1 of x is equal to x squared minus 3. Okay. So there it is. So that's what you have to do today. You're going to look at functions and they're going to look at their inverses. Remember, they're 1-to-1. If each x value maps onto one y value and each one y value maps onto an x value. And honestly, anytime you get a function, you go into Desmos. If you're not quite sure if that horizontal line test would work, go ahead and type it into Desmos and look at that horizontal line and see if that works. So it looks like I was just looking at your assignment a couple seconds ago, and then I flipped the page. And then, of course, I don't know where it's at, so I probably deleted it like some bonehead. Anyway, like 11 questions or so on your assignment today, or something like that in section 11.1, 10 actually. So 10 questions on your assignment today. It's sitting there. Again, if you have questions, please make sure you ask. Have a good day, everybody.